In this lecture, we're going to walk through performing a simple regression in Excel. We're going to use a couple different ways to approach this. The first of those will involve starting by graphing the data first, and then we'll use that to see the problems with the methods. It just doesn't include all the necessary information that we need. So it'll sort of serve as a warning to show what we're lacking. Then we'll look at the second way, which is better, it includes all the information. Now we have the same data here that we had for a correlation example, except one thing to notice is that I've changed the order of the variables. So we have temperature first, and then we have consumption. The reason I did this is because of the way that Excel deals with graphing variables, the way it chooses which variable to appear on the plot. So sometimes in your work, you may need to switch the order of columns just in order to get Excel to graph things the way you want them to be graphed. It's no big deal. All the values are the same, so you can feel perfectly free to change the order. So here we have consumption and temperature. So I will just highlight them and create a scatter plot real quick. And here we have a scatter plot showing consumption and temperature. So I'll put my cursor into the scatter plot here and then right click on that, and we can add a trend line. I want to make sure we have the linear option selected, which we do. And we don't need to change anything else. So here we have that line of best fit. Actually, yeah, I will click display equation and display R squared. Now we can see both of them. So we have the actual values. I'll put them up here in the space where we can, actually read it. So the equation is y equals a plus bx. So in this case, y equals 1.82 times x plus 160.57. So one thing to know in particular about this method is that when you do the graphical analysis to get this line of best fit, you have to have, in this case, the temperature first. You have to put the X variable first because of the way Excel deals with this. So that's one tricky thing that you may, that can trip you up when doing this. The second is that you don't get a p-value. Notice we have the R squared and we have the equation itself, but no p-value, nothing to tell us the statistical significance. And p-value is really important. So the other way to do this problem in Excel, which is the more complete way, would be to use the data analysis tab, which does things really great for us. We've been using it in most of these examples. So here we scroll down, we just select regression over here. So we can input the y variable. The y is what we think would cause the other variable to change. So we think consumption would change based on the temperature. So our y variable is consumption. So this time it does matter. Click here, consumption. And then here for the X range, select the temperature. I will select that there are labels because I included the labels in here. And for the output range, I'll just select to have it here on the in this window. And then just hit OK. Gives us the results. Okay, so notice we get the R squared right here. If we remember the previous example, because the calculating the same thing, we had the same R squared before. Because our R squared is about 0.75, a little over 0.75. About 75% of the variation in electricity consumption can be explained by the temperature. The next thing we want to look at is the F statistic and its p-value. We use this to test the p-value to test the statistical significance of the F statistic. So since the p-value of the F statistic, so here's the F statistic, they just call it the significance, but that is the p-value. Now it's very, very small. It's an exponent to -10. So this is very close to 0. Because that's a lot smaller than 0.05, we have evidence that the relationship between the two variables in this model does exist. The final thing we want to look at here is the coefficients. So the coefficients we use to develop our function. Using them, the equation would be y hat, or the projected consumption, would be equal to the intercept. So that is here 160.56 minus 1.8227 times x. So notice these two numbers here, the intercept of 160 is the same as the intercept up here. And the coefficient here, negative, is the same up there. Notice we get the same r squared here and up there. So using the line of best fit in Excel to fit to a scatter plot does actually give you accurate answers. It doesn't tell you the wrong thing. It doesn't do the equation incorrectly. It just doesn't give you all the information that you need. So you can't, like, for instance, evaluate the statistical significance. Here we see p-value 1.29 to the negative 10. So this is very, very small. So this, we say that the coefficient for temperature is statistically significant. And it's important to make sure that we include that so we can evaluate the fit of our model.